So welcome back to 1.5, more on slope, more algebra 1, more algebra 2, more graphing, more equations. Hopefully, again, this has all felt like an algebra 1 or algebra 2 review. The main objectives for this section, finding slopes and equations of parallel and perpendicular lines. Also interpreting slope as a rate of change. Well, we did that a little bit in 1.4. I think the new thing that's coming into play eventually towards the end is finding a function's average rate of change. The first objective in particular is really going to hit with these first two examples. You might notice that we have a refresher up here with linear equations, standard form, slope-intercept form, point-slope form. We'll also sketch in slope formula in case we need it. If you've already memorized these, that's awesome. If you're en route, that's cool too. But keep in mind, this is here to help you. If you get stuck, chances are you can go back to these equations and make some type of progress. So always look back if you get stuck or think it out. You might notice the Mario Brothers at the top. The reason I included them is that I think it's a really interesting way to remember how exactly lines run parallel. You might think, well, they look like railroad tracks. If they're parallel, they never intersect, yada, yada, yada. As far as the algebra interpretation, I think that helps referring to the Mario Brothers because they have the same mother, different brother. If I taught you in Algebra 2, you might remember this. But the reason I included here talking about parallel lines is because ideally they're brothers. Ideally, they have the same mother, the same M, the same slope. So parallel lines have the same slope, but different brothers. These are two different brothers. Mario is not Luigi. They have different B's. That's why I highlighted on that. So they have the same slope, but different y-intercept, different B term. Because in slope-intercept form, you'll see B, which is representing the y-intercept. So they have the same slope, same mother, different brother. That should help you if you get stuck remembering parallel lines. Perpendicular, however, I haven't thought of a clever way to think of this. If you think of one, definitely let me know. Where the slopes, when multiplied, should be equal to -1. You might refer to them as negative reciprocals of each other, flipped around fractions, in which case that works just fine too. So with this first example seen here, we're being asked to write the equation of the line in slope-intercept form, passing through this point, -3, -1, and running parallel to this equation, y equals -1/2 x minus 5. So we don't necessarily have to graph here. We're just writing out an equation, which is totally okay. We know that if this is running parallel, we could think of that with the Mario Brothers, same mother, different brother, same slope, different y-intercept. The reason I use B for brother is because in slope-intercept form, they use that B to determine the y-intercept. So we know that if we're trying to make an equation that runs parallel to this, we need to reuse the slope that's given here, which in this case is -1/2. So the slope that runs parallel is going to be -1/2. We also need this line to run through -3, -1. Which equation do you think is going to make the most sense here to use? Well, we don't necessarily know the y-intercept, so slope-intercept is off the table for now. But point-slope form, we can use that. We know our slope. We know a point that's in there. So let's use that to start. If we have y and we're deducting the y-coordinate, which is -1, this is equal to the slope, in this case -1/2 with parentheses. X-coordinate is x is x, and then we're subtracting -3. If we rewrite the left-hand side, subtracting -1, it's the same thing as adding 1. Beginning to distribute that -1/2, we have -1/2 x. Distributing that to what's eventually going to be a +3. But the negative 1/2 switches that back to negative. It gets us here. So we now have y plus 1 equals negative 1/2 x minus 3/2, isolating for y because we want to go to slope-intercept form, deducting 1 on both sides. We end up with y equals negative 1/2 x minus 5/2, because again, we're deducting 1. And this is going to be our final answer. We know we're at our final answer because the slope is the same. They have different y-intercepts. And I put the calculator here also because you can check your work if you'd like by just graphing this out, whether you use Desmos or use your calculator. We can check and make sure that these two lines are going to run parallel to each other, and also make sure that it's going to hit the point -3, -1 for the second equation that we made. If we continue to problem 2, we're being asked to find now an equation that runs perpendicular to 3x plus y equals -4, but also hits the point -5, -3. So we're being given our equation in standard form. Hopefully that's easy to spot. How can we get a hold of the slope? Because the slope's really crucial, so we need to find a slope. How do you think we can get a hold of the slope for this equation here? I'll give you a moment. Well, although we're in standard form, if we isolate our y term and go and take this to slope-intercept form, that should pretty quickly tell us what the slope's going to be. So if we go to slope-intercept form, subtracting 3x will help us isolate y. So the new equation we have is -3x minus 4. Hopefully we can see that the slope that's given from this equation is -3. I'll call this M1. To get a hold of the line that runs perpendicular to this, however, we know that the product of the two slopes should be equal to -1. If we solve this new slope that we're going to use is going to be positive 1/3. So that's the slope that we're going to need. They want us to go to slope-intercept form, and we'll do that soon. We know we have our point of -5, -3. We know our slope is 1/3. If we use point slope form now, we are subtracting -3. This is equal to 1/3 x subtracting -5. Rewriting this to +3. Distributing 1/3 to 1/3 and then x. Eventually distributing to this +5, so we're adding on 5/3. Trying to go to slope-intercept form, so deducting the 3. We have y equals 1/3 x minus 4/3. A little bit of fraction work here, so be careful. And I know that these are going to be perpendicular each other because the slopes -3 and 1/3 are negative reciprocals of each other. They also have different y-intercepts. Not that that's something that needs to happen, but it helps. We could also plug in this -5, -3 to this equation, and that would be a logical statement. If you're not convinced, you can always try it out. And that will eventually get us to -9/3, which is definitely -3. So this definitely hits the point.